in the previous class we are starting, that is the gravitational self energy. We are already seen the definition of gravitational self energy of a body and short part of gravitational self energy of a body, that is the expression for the gravitational self energy of the body. So in the previous class we calculate here in the gravitational field of m1 the potential energy u1 is equals to minus of g m1 summation of j is equals to 1 to n mj divided by r1j, that is here the combination of m1 and m2. So that's why the distance between m1 and m2, that is the r1 distance from first particle, that is m1 particles, to second particle, that is here j is not equal to 1. This is the first number equation. So this is the in the gravitational field of m2 the potential energy of the remaining particles u2 is equals to minus gm2 summation of j is equals to 1 to n mj divided by r2j, because this is the in the gravitational field of m2, here we write r2j, here j is not equal to 2. Then again in the gravitational field of m3 the potential energy of the remaining particles, that is u3 is equals to minus of g m3 summation of j is equals to 1 to n mj r3j, here j is not equal to 3 because we can't calculate the distance between the same particles, that's why j is not equal to 3. Here j is not equal to 3 means 1 2 4 5 6 up to n number. So this is the expression, this is the third number expression, third number equation. So we have to find the gravitational self energy of the body, so that's why we have to find, or we find if we find the sum of these all potential energies in the this, if we sum, that is u1 plus u2 plus u3 plus dash up to un, so we calculate the gravitational self energy of the body. But in the calculation here the terms, that is in the first equation two terms in the equation first and equation second, or all two means mixedly if we calculate this up to mn, so there are the two terms exist where are the twice in term, that is in the equation first we write here minus of g, here m1 for the first particle and here m2, and the distance between r1 2. So this is a one term of equation first, and in the equation second here minus g of m2, and if we write here m1 divided by distance of 2 and 1. Okay, so these terms are same because distance between r21 and r12 are the same term, means in the summation term some term, each term occur twice. This is the first term, this is the second term, so this term in the all equations two terms are same, that means it occurs in twice. Okay, so this is in equation first, this is in equation second, so that's why if we calculate the self energy of the body, so that is the total potential, that is u1 plus u2 plus u3, so we have to divide given equation or dividing the sum of this equation by the 2. Okay, so thus the sum of potential energy, that is capital U is equals to u1 plus u2 plus u3 plus u4 up to dash un. Okay, and this sum of potential energy is nothing but gravitational self energy. Therefore the self energy of a body, that is u is equals to, here the term minus 1 by 2 g we take a common, so this is the reason we have to write this 1 by 2, because each term occurs twice in the summation term, that is minus 1 by 2 g, and here the term m1 for the first term and summation j is equals to 1 to n, here mj divided by r1j plus m2 summation j is equals to 1 to n mj divided by r2j plus m3 summation j is equals to 1 to n mj divided by r3j. Here in the first term j is not equal to 1, in the second j is not equal to 2, in the third j is not equal to 3, and plus dash up to mn term. Okay, so if we calculate this, u is equals to minus 1 by 2 and g. Okay, so here observe this term m1, m2, m3, then next m4, m5 up to mn. So we write this as a first summation, I is equals to 1 to n, and here mi. Okay, mi, and next summation we know already, that is j is equals to 1 to n, here mj, and divided by r I j. Okay, here I means 1 to n, here also 1 to n means 1, 2, 3, 4, 5, 6 up to n. So that's why we take here r I j here, and here I is equals to 1 to n, here j is equals to 1 to n. And again we can write if we where j is not equal to here 1. This j is not equal to 1. Okay, so therefore if we calculate mixedly, u is equals to minus 1 by 2 and g. If we calculate this in the mixed form, so equating, that is summation I is equals to 1 to n and summation j is equals to 1 to n, here j is not equal to 1, and in the summation part mi mj divided by rij. So this is the formula for the gravitational self energy of a body, that is u is equals to minus 1 by 2 g summation. We write this summation in the equally part, that is summation mixed together, summation I is equals to 1 to n, summation j is equals to 1 to n, mi mj divided by rij. So this is the expression for the gravitational self energy of the body consisting n number of parts. Okay, then we will see the physical significance of this equation. Here double summation meanings, double summation notation, that is summation I is equals to 1 to n and summation j is equals to 1 to n. This is the double summation, and the double summation notation where j is not equal to 1 means that is take I is equals to 1. Okay, if we take I is equals to 1 and sum over j is not equal to 1, that is j is equals to 2, 3, 4, 5 up to n. Okay, j is not equal to 1, but here if I is equals to 1, here the term if I is equals to 1, then the remaining term j means 2. Okay, 3, 4, 5 and up to n. Here rij, if we take r is equals to I is equals to 1 means r1, and here j is equals to 2. r1 2 means distance between first particle m1 particle to m2 particles. Okay, take I is equals to 1 and sum over j is equals to 2, 3, 4, 5, 6. Take I is equals to 2 and sum over j is equals to 1, 3, 4, 5 up to n. Okay, you got it? Then if I is equals to 3, sum over j is equals to 1, 2, remaining 3, that is 4, 5 up to n. You got it? Then if I is equals to 4, sum over j is equals to 1, 2, 3, 5 means except n. If we take I is equals to 1, remove this 1. If we take I is equals to 2, remove this 2, remove this 3, remove this 4. Okay, so that type of double summation notation means here double summation meanings. Okay, so this is the expression for the, and this continue up to I is equals to n, means here sum over j is equals to 1, 2, 3, 4, 5 up to n minus 1. not n minus 1. Okay, so this continue up to n numbers. Here j is equals to, if we take n, so here n minus 1. Okay, so this is the expression for the gravitational self energy of a body. So in the next class we will see the Kepler's laws of motion and the geosynchronous orbit or satellite. Okay, thank you.